Have you ever wondered if time travel was possible? Well, it is, and there are actually two aspects to it. Traveling in time to the future is possible. However, traveling back in time is in fact impossible. Let's first look at the aspect of traveling in time to the future. This is done all thanks to the concept of time dilation. So here we have the equation for time dilation. T denotes our elapsed time according to our clock, which is at rest with respect to us. This is also known as proper time. T prime, on the other hand, denotes the elapsed time in another time frame. And this bottom portion over here can be denoted by gamma. As you can see, it's kind of substituted into this equation. And this is basically the Lorentz factor. It pretty much shows how much time slows down, where v is your velocity. Let's now look at an example where we will be using the time dilation equation. So we have two people here. One of them's Alex and the other one's Bob. Bob is on Earth while Alex is in outer space on a rocket ship that's traveling at 90% the speed of light. We'll take his elapsed time, which is the change in t, to be 1 second. So we're trying to find t prime, which means that for every 1 second that's elapsed for Alex, what is the amount of time that actually is elapsed for Bob with respect to Alex? So we substitute in the numbers. So since v and c are kind of like ratios of each other, because we're traveling at 90% speed of light, I can substitute v equals to 90 and c equals to 100. Solving this, I actually get t prime equals to 2.29 seconds. What this means is that Alex, who's traveling at 90% speed of light, for every 1 second that passes by for him, 2.29 seconds actually passes by for Bob. This is basically time dilation, whereas one travels closer and closer to the speed of light, the slower time passes. So, you might be wondering, what has all that got to do with traveling in time to the future? So take for example that Bob and Alex are actually twins. If Bob has aged 10 years on Earth, Alex, who's traveling at 90% the speed of light, would have time that passes by more slowly, relative to Bob. So Alex would actually only have aged 4.36 years in the 10 years that Bob has aged on Earth. So if Alex were to actually return to Earth, we see that he is currently at the future Earth and has traveled in time to the future. So this is how time dilation allows one to travel in time to the future. Let's now talk about the impossible, traveling back in time. Many assume that if I travel closer and closer to the speed of light, time slows down. If I travel at the speed of light, time is said to be frozen. So what happens if I travel faster than the speed of light? They say that by traveling faster than the speed of light, it would indicate traveling backwards in time. However, this is impossible, simply because in order to travel back in time, we'd need to travel faster than the speed of light, which is just not possible. So let me explain why. So in order to explain this, we would need to use Einstein's famous equation E equals to mc squared. This equation, however, can only be applied to objects at rest. So for us dealing with objects in motion, we would need to use this equation instead, where relativistic mass is basically the Lorentz factor times the rest mass. So the rest mass is pretty much the mass that we all know of, which is the mass an object has in its rest frame. Relativistic mass, however, actually includes the energy that a body possesses, in addition to its rest mass. So, knowing that mass contributes to an object's inertia, which is the resistance an object has to a change in the state of motion, we see that as objects move at speeds close to the speed of light, there's a need for more energy to be added in that object for the same change in velocity. Since it's such a high relativistic mass, high kinetic energy, and thereby a very high inertia. So for example, if I travel at 10% speed of light, I would only need 0.5% more energy for the same change in velocity. However, if I travel at 90% speed of light, we see that we need twice as much energy just for the same change in velocity. We thereby see that as an object approaches the speed of light, its inertia rises ever more quickly to infinity, so it takes more and more energy for it to speed up. It therefore cannot reach the speed of light or travel faster than the speed of light, simply because it would take an infinite amount of energy to get there. So I hope you understand more about time travel and why we can travel in time to the future and not travel in time to the past. Thanks for watching.